everyone, Jason from Makera here with another Carvera Air tutorial. And in this one, we're looking at how to create the LED light example from the examples guidebook that comes with your Carvera Air desktop CNC. The examples guidebook comes with every Carvera Air along with a sample pack of materials that can be used to complete these projects. The design files and bits are also included with your Carvera Air, so making these projects are an easy and satisfying way to get started with CNC production. Now, the LED light project is actually one of the more complex example projects because there's multiple parts that need to be manufactured in order to finish the project. But the first part of the LED light project, the printed circuit board, is actually optional. This is because the sample materials pack not only includes all the electronic components to make your own PCB, but also includes a fully assembled PCB that you can use as well. But if you do want to make your own PCB for the LED light project, there's actually two different ways that we can do this. One method is creating a very simple unmasked copper PCB, or if you also have the PCB fabrication pack, we can create a masked PCB instead. For either option, we can start by securing a single-sided PCB board that is 150 by 100 by 1.5 millimeters over a cut piece of wasteboard as shown in the examples guidebook. And while it's not required, we often remove the dust shoe and use air assist whenever machining PCBs or metal. Next, launch the Carvera controller app and connect to your Carvera Air. We can then load the file titled PCB No UV Mask from the LED folder in the examples project if we don't want to create a masked PCB. This file includes all of the paths and steps to make a completed unmasked copper PCB. Next, click Config and Run and set the offset to be 15 millimeters in the X direction and 10 millimeters in the Y direction from anchor point 1. We want to use scan margin and auto Z probe, as well as auto leveling with 5 points in the X direction and 5 points in the Y direction, and a clearance height of 2. This is because PCB boards tend to warp, so by auto probing multiple points on the surface of your PCB board, an even and consistent cut can be created with even depth through the entire PCB. We can also apply double-sided tape to the back of the PCB to actually adhere it down to the piece of wasteboard that we secured earlier, and this will help keep your PCB nice and flat during machining as well. Once you're ready, click Run to start this job. The Carvera Air will first prompt you to load the wire probe, then use the probe to trace the perimeter of our part using the laser pointer built into the probe. Ensure that this laser does not overlap with any screws or clamps. The Carvera Air will then measure the Z height across the stock to make a consistent map for machining. Running the non-masked PCB will take about 35 minutes as the Carvera Air prompts you to switch between Tool 2, the 30-degree V-bit, which will be used to machine the traces of the PCB, followed by Tool 3, the 0.8 millimeter corn bit that will be used to manufacture the holes and perimeter cuts in the design. When this finishes, you can send the Carvera to its clearance position or home position and then vacuum the part before removing it from the Carvera and cutting the tabs using the handsaw included in your materials kit. Now, alternatively, we can take full advantage of the optional PCB fabrication pack to make a masked PCB instead using a very similar setup process. Again, we would start by securing a single-sided PCB board that's 150 by 100 by 1.5 millimeters over a cut piece of wasteboard as shown in the guidebook, and using double-sided tape is a good idea as well. Next, launch the Carvera controller app and connect to your Carvera Air. We can then load the first file, which would be titled PCB UV Mask Part 1 from the LED folder in the examples project within the app. Click Config and Run and set the offsets to be 15 millimeters in the X direction, 10 millimeters in the Y direction, both from anchor point 1. We then want to use scan margin and auto Z probe, as well as auto leveling with 5 X points, 5 Y points, and a clearance height of 2. And when set, we can click Run. The Carvera Air will again prompt you to load the wired probe and use this probe to trace the perimeter of our part using the laser pointer built into the probe. The Carvera Air will then measure the Z height across the stock to make a consistent map for machining. The Carvera Air will then prompt you to load Tool 2, the 30-degree V-bit, and machine just the traces of our PCB using the V-bit, which will take about 15 minutes. After this job finishes, you can move the tool head away from the PCB by clicking Go to Clearance in the Carvera controller app. But do not remove the PCB and do not turn off your Carvera Air. Using the PCB fabrication pack, we can apply a UV solder mask with the resources included in this kit. To do this, we first want to lightly sand the surface of the PCB to scuff it so that way the mask adheres better. We can then apply the mask in a thin coat, as it's better to apply multiple thin coats of the UV mask evenly using a roller rather than a single thick coat. Wear gloves, as you should not handle uncured mask with your bare hands. In between coats, we can use the UV curing lamp, which can be powered via the USB charging port on the back of the Carvera Air, to cure each mask layer. Typically, 2 to 3 layers should provide an effective solder mask. Excess UV mask on the roller or clamps can always be cleaned up with alcohol wipes. Once the PCB is masked and fully cured, return to the Carvera controller app and open the PCB UV Mask Part 2 file. We want to ensure that our work origin is the same as the first job, but we do not need to use scan margin, auto Z-probe, and auto leveling, as these parameters were obtained when we did our first file. Once configured, click Run. The second UV mask file should run for about 20 minutes, and the Carvera Air will first prompt you for Tool 6, the solder mask removal tool, which is included in the PCB fabrication kit. This is used to expose bare PCB copper under the mask where we need to solder our components. The Carvera Air will then pause and prompt you to load Tool 3, the 0.8mm corn bit, and this is again used to drill the holes and cut the perimeter of our PCB. When completed, we can move the head out of the way, vacuum the part, and remove it from the Carvera, carefully cutting the tabs to release it from the PCB board using the saw provided in your sample pack. You can also use the sanding block to sand the edges as needed. Now we'll go over soldering the PCB later, but for now it's time to manufacture the second part, which is the ABS plastic base. Secure a 150 by 150 by 20mm ABS plastic board in the Carvera Air with a single piece of wasteboard beneath it as shown in the examples guidebook. We can then load the ABS base file located in the LED examples folder within the Carvera controller app. In the config and run window, we first want to set the work origin to be 15mm in the X direction and 20mm in the Y direction from anchor point 1. We then want to enable scan margin and auto Z-probe as well as auto leveling with 5 X points, 3 Y points, and a clearance height of 2. Once set, click Run to start manufacturing. The base file should run for about 40 minutes. The Carvera Air will first prompt you to load the wired probe and then use the probe to trace the perimeter of our part using the laser pointer built into the probe. Ensure that the laser does not overlap with any clamps or screws. The Carvera will then measure the Z height across the stock to make a consistent map for machining. After measuring the Z height across the part, the Carvera Air will prompt you to insert Tool 1, the 25mm single flute end mill. This is used to machine the pockets of our signed base. As always, you can preview the toolpaths within the Carvera controller app during machining, as sometimes it's difficult to see what cuts are being made. The Carvera Air will then pause and prompt you to load Tool 2, the 30-degree V-bit, which will be used to quickly clear out some holes in the base. Lastly, the Carvera Air will again prompt you for Tool 1 to finish cutting the perimeter of the part. Once finished, vacuum the part before removing it from the Carvera Air. You can then carefully use the hand saw provided in the materials pack to cut away the base from the remainder of the stock. And the next part that we're going to manufacture is the acrylic display board for our LED sign. Peel the top layer of protective mask off the acrylic before securing the 150 by 180 by 4mm acrylic plate over a piece of wasteboard as shown in the examples guidebook. Within the Carvera controller app, there are multiple acrylic display board files to choose from in the LED examples folder. After selecting a file, you can preview the design before clicking Configure and Run. We want to set the work origin to be 15mm in the X direction and 25mm in the Y direction from anchor point 1. We also want to enable scan margin and auto Z-probe and auto leveling with 5 X points, 5 Y points, and a clearance height as 2 as we've done earlier. Once configured, click Run to start this part. The Carvera Air will first prompt you to load the wired probe and then use the probe to trace the perimeter of our part using the laser pointer built into the probe. As always, ensure that the laser does not overlap with any screws or clamps. The Carvera Air will then measure the Z height across the stock to make a consistent map for machining. After measuring the Z height across the part, the Carvera Air will prompt you to load Tool 2, the 30-degree engraving bit, before machining the design, which will take approximately 30 minutes depending on the design that you chose. The Carvera Air will then pause and prompt you to load Tool 4, the 12mm single flute end mill to cut out the outer edges of the part. The display board will not be machined with tabs, but instead a perforated V-groove which can be carefully broken after removing the part from the Carvera. To do this, place the V-groove over the corner of a table and carefully snap the display board away from the stock. And the final part to manufacture for our sign base is the aluminum touch switch. Start by securing the aluminum stock that's 100 millimeters by 100 millimeters by 5 millimeters over a cut piece of wasteboard as shown in the examples guidebook. And while it isn't required, we often remove the dust shoe and use the air assist nozzle whenever machining PCBs or metal. Next, launch the Carvera controller app and connect to your Carvera Air. Within the Carvera controller app, open the aluminum button file from the LED examples folder and click config and run. We want the work origin to be 10 millimeters in both the X and Y directions from anchor point 1. We also want to enable scan margin, auto Z probe, and auto leveling with 3 X points, 3 Y points, and a clearance height of 2 as this is a much smaller part. When set, we can click run to start the job. The Carvera Air will again first prompt you to load the wire probe and then use the wire probe to trace the perimeter of our part using the laser pointer built into it. Ensure that the laser does not overlap with any screws or clamps. The Carvera Air will then measure the Z height across the stock to make a consistent map for machining. After measuring the Z height across the part, the Carvera Air will then prompt you to load tool 4, the 12 millimeter single flute end mill, before beginning to machine the switch, which will take about 20 minutes. Once finished, carefully vacuum away any excess material shavings and remove this part from the Carvera Air. You can carefully cut the tabs to release the part from the stock using a handsaw and use sandpaper or a file to even out the edges. So now it's time to assemble our LED sign using all the parts that we've just manufactured. And the first step would be soldering our own PCB board if you chose to create your own PCB board. Whenever you're soldering, make sure you're doing so in a well-ventilated space with some type of fume extraction system, and always remember to wear your safety glasses. In addition to the PCB and components included in the example materials kit, you will need a soldering iron, cleaning sponge, solder, and wire cutters to complete this part of the project. When soldering our components, we soldered on the mass side or copper side of the PCB, which is the bottom of the board. Start by inserting the 2 ceramic capacitors as shown on the example PCB included in your kit. The large capacitor will be placed on the outside edge, while the smaller one is on the inside. These capacitors are non-polar, meaning that their orientation does not matter. To solder a PCB, we first want to heat the bottom of the hole and the leg of our component before adding solder. This allows for the solder to flow evenly between the component and PCB board rather than just up the leg of the component. After soldering both capacitors, use your wire cutters to trim off the excess legs. Next, solder the larger capacitor in the correct location on the opposite side of the board. This component is polar, so the stripe should be placed inwards. Leave some room as you insert and solder the capacitor so you can fold it flat after soldering. We can then solder the USB-C port, which should snap into place on the opposite end of the PCB. Be careful as this part will get very hot during the soldering process. We then have multiple resistors across the PCB, all of which are non-polar, meaning that the direction that you insert them is not important. The 100 ohm or brown, black, 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 brown resistors can be soldered down the center of the PCB between where the LEDs go. The 0 ohm single black stripe jumper resistor can be soldered between the last 100 ohm resistor and the USB-C port. On the opposite side of the PCB, we want to solder the 1K ohm or brown, brown, black, black resistor next to the transistor and capacitors, while the 4.7K yellow, violet, black, brown resistor will go on the opposite side closest to the ceramic capacitors. Next, using one of the legs cut off of a component, solder the touch switch jumper between the 2 points on the far end of the PCB. You want to allow this to be raised as this will touch the metal button once fully assembled. We can then carefully install the integrated circuit so that the notch is facing the USB-C port. When soldering this chip, it's okay if solder connects between the capacitor legs and the chip legs from within the same row as these components are interconnected. As always, ensure that you clean off the tip of your soldering iron to prevent excess solder from being deposited during the soldering process, and be careful as integrated circuits are easy to overheat. Next are the LEDs, which are polar. The longer leg is the anode or positive, which will be threaded through the round holes or the outer holes along the bottom edge of the PCB, while the shorter leg or cathode should be threaded through the square holes or the inner ones. Next, solder the transistor so the flat side is facing inwards before trimming the legs and folding the transistor flat on top of the PCB. After you finish soldering and trimming the excess legs, you can plug in the PCB to test it. Just tap the jumper on the end of the PCB to control the brightness. And then finally, you can assemble it all together. You can glue the aluminum switch into the ABS base within the pocket on one of the sides of the base. You can then secure a soldered PCB using the 4 screws provided. Ensure that the USB-C port aligns with the opening and the jumper aligns and touches the aluminum touch switch. Lastly, insert the acrylic sign after peeling off any remaining protective film into the top of the base. All that's left is to connect the sign to a power source, then tap your switch to adjust the brightness. So this example project really showcases the versatility of the Carvera Air desktop CNC, as we just manufactured so many different parts out of a wide range of materials to create this finished product. I hope that you enjoyed watching this tutorial as well as following along with the examples guidebook. Of course, please don't forget to subscribe and stay tuned for more projects and guides on the Makera channel and Wiki site.